Good morning. This is D. Sujata, Assistant Professor in Botany, Government Degree College, Women's, Karimnagar. Now I am going to give a lecture on glycolysis. Glycolysis. This is the initial phase of respiratory metabolism of carbohydrates. So this glycolysis pathway is also called as EMP pathway. EMP means here three German scientists, Emden, Meyerhoff, Parnas. These three scientists investigated the reactions which takes place in glycolysis pathway. On the honor of these three scientists, this pathway is also called as EMP pathway. Glycolysis means this glycolysis derived from the Greek words. Glycis means sugar. Lysis means breakdown. That means the sugar breakdowns into simple substances. So glycolysis means breakdown of sugar. So in this glycolysis pathway, one molecule of glucose degraded into two molecules of pyruvic acid. So this glycolysis pathway is present both in aerobic and anaerobic respiration. This glycolysis pathway takes place in cytoplasm. In this pathway, there is no utilization of oxygen and there is no liberation of carbon dioxide. At the end of this glycolysis, 2 NADH plus H plus and 2 ATP formation takes place. This is the flow chart of glycolysis. In this glycolysis pathway, there are 10 reactions takes place. So the first substrate is glucose. So this glucose undergoes many reactions and at the end, 2 molecules of pyruvic acid produced. So glucose is a 6-carbon compound which degraded into 2 molecules of pyruvic acid. This pyruvic acid is 3-carbon compound. Phosphorylation. So this phosphorylation is the first reaction in glycolysis. Phosphorylation means taking phosphate. So here the glucose, the substrate, glucose is phosphorylated by taking phosphate from ATP and this glucose converts into the glucose 6-phosphate. So here phosphate donor is ATP. So this reaction catalyzed by hexokinase enzyme. So the glucose in the presence of hexokinase enzyme, it takes phosphate from the ATP and converts into the glucose 6-phosphate. So this ATP converts into ADP. So the products are the glucose 6-phosphate and ADP. The second reaction in glycolysis is isomerization. Isomerization, here the glucose 6-phosphate, here the glucose 6-phosphate, it converts into fructose 6-phosphate. Glucose 6-phosphate isomerized to fructose 6-phosphate. Here glucose and fructose both are isomers. So here the rearrangement of chemical structure of the carbonyl oxygen takes place. The carbonyl oxygen which is present on the C1 carbon, it transfers to C2 carbon, forming the aldose to ketose sugar. So here the isomerization takes place, that is glucose 6-phosphate converts into the fructose 6-phosphate. Here the enzyme is phosphohexoisomerase. So the glucose 6-phosphate in the presence of enzyme phosphohexoisomerase, it isomerized to fructose 6-phosphate. So after this isomerization, this glucose 6-phosphate converts into the ketose, fructose 6-phosphate. That is the fructose 6-phosphate. And next, third reaction in the glycolysis is the phosphorylation, again taking phosphate. Here also the phosphate donor is ATP. Here also the phosphate donor is ATP. Here the fructose 6-phosphate, it takes the phosphate group from the ATP in the presence of enzyme phosphofructokinase and converts into the fructose 1,6-bisphosphate. That means this fructose, it is a 6-carbon compound. So the phosphate group is present on the first carbon and 6th carbon. So in the presence of enzyme phosphofructokinase, the fructose 6-phosphate converts into the fructose 1,6-bisphosphate. Here it takes phosphate from the ATP. So ATP converts into the ADP. Next, fourth reaction is the breakdown or cleavage reaction. It is the major step in the glycolysis. In this breakdown or cleavage reaction, the 6-carbon sugar, that is fructose 1,6-bisphosphate. The 6-carbon sugar fructose 1,6-bisphosphate cleaved and form two molecules. That is, fructose is a 6-carbon compound. It forms the 3 compound, that is 3 carbon compounds. There are 3 carbon compounds. Those are the one is glyceraldehyde 3-phosphate and another one is dihydroxyacetone phosphate. So in the presence of triose phosphate isomerase, the fructose 1,6-bisphosphate, it cleaved into 2 products. Those 2 products are the 3 carbon compounds. One is G3P, glyceraldehyde 3-phosphate, and another one is dihydroxyacetone phosphate. Next, fifth reaction is the isomerization. Isomerization, here also, in the previous reaction, 2 compounds are produced. One is glyceraldehyde 3-phosphate and another one is dihydroxyacetone phosphate. So in these 2 compounds which are formed in the previous reaction, that is cleavage reaction, only one of the triose sugar, that is G3P only, participate directly in the glycolysis pathway. Directly in the glycolysis pathway. So this dihydroxyacetone phosphate and G3P, both are isomers. So, but in the next reaction, only in the form of glyceraldehyde 3-phosphate only, it participate in the glycolysis pathway. So, this dihydroxyacetone phosphate, in the presence of triose phosphate isomerase enzyme, it oxidizes to glyceraldehyde 3-phosphate. So this glyceraldehyde 3-phosphate, next it participate directly in the glycolysis pathway. And this is the oxidation reaction. So in this oxidation reaction, in the previous reaction, that is the glyceraldehyde 3-phosphate, the 2 molecules of glyceraldehyde 3-phosphate are oxidized in the presence of enzyme glyceraldehyde 3-phosphate dehydrogenase. Glyceraldehyde 3-phosphate dehydrogenase catalyzes the conversion of the G3P into 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. So here the oxidation of glyceraldehyde 3-phosphate takes place in the presence of G3P dehydrogenase and forms the 1,3-bisphosphoglycerate. So here for the phosphorylation reaction also takes place here. Here the phosphate group for the phosphorylation reaction is takes from the cytoplasm. In the cytoplasm, that is inorganic phosphate is present. So this inorganic phosphate which is present in the cytoplasm is utilized for this phosphorylation. So here the aldehyde, it converts into the carboxylic acid, that is G3P converts into the 1,3-bis-phosphoglyceric acid. So in this oxidation, the hydrogen are released from the glyceraldehyde 3-phosphate. So the hydrogen which are released from the oxidation of the G3P are taken by coenzyme NAD, and this coenzyme NAD is reduced to NADH plus H plus. So here in the glycolysis pathway, in this oxidation reaction, here two molecules of NADH plus H plus are produced. So here the glyceraldehyde 3-phosphate oxidized and converts into the 1,3-bis-phosphoglyceric acid. Here the NAD converts into the NADH plus H plus. Next reaction in the glycolysis is the dephosphorylation. Dephosphorylation, here dephosphorylation means that is losing of phosphate group. Losing of phosphate group. Here 1,3-bis-phosphoglyceric acid. That means 1,3-bis-phosphoglyceric acid means that is present the phosphate group on the first carbon and third carbon. So this 1,3-bis-phosphoglyceric acid, it loses one of its phosphate group to ADP. So the phosphate group which is lost by the 1,3-bis-phosphoglyceric acid is taken by ADP. Then ADP converts into the ATP. So here the 1,3-bis-phosphoglyceric acid converts into the 3-phosphoglyceric acid. In the previous 1,3-bis-phosphoglyceric acid, there are the phosphate group present on the first carbon and third carbon. But it loses the phosphate which is present in the first carbon. So that phosphate which is lost by the 1,3-bis-phosphoglyceric acid is taken by ADP. Next, this ADP converts into the ATP. So this 1,3-bis-phosphoglycerate in the presence of the phosphoglycerokinase enzyme, it converts into the 3-phosphoglyceric acid. So here two molecules of ATP are produced. So here phosphorylation taking place, that is the conversion of the ADP into ATP. So here this ATP, the ADP is taking the phosphate group from substrate, that is 1,3-bis-phosphoglyceric acid. So here it is getting the phosphate from the substrate. So this phosphorylation is called as substrate level phosphorylation. Next reaction in the glycolysis is interconversion. Interconversion. Here, interconversion, the phosphate ester linkage. The phosphate ester linkage in 3-phosphoglycerate is moved from C3 to C2 and form 2-phosphoglycerate. So here 3-phosphoglycerate is converts into the 2-phosphoglycerate in the presence of enzyme phosphoglycerate mutase. Here the phosphate ester linkage, which is present in the third carbon, it transfers to second carbon. Okay, the ester linkage, the phosphate ester linkage, which is present on the C3 carbon, is transfers to C2 carbon in the presence of enzyme phosphoglycerate mutase. So the 3-phosphoglycerate is converted into 2-phosphoglycerate. Next reaction is the dehydration. Dehydration means losing of water molecules. losing of water molecules. Here 2-phosphoglycerate, it loses water molecule and it converts into the PEP, that is phosphoenol pyruvic acid. Phosphoenol pyruvic acid. In the presence of enolase enzyme, 2-phosphoglyceric acid, it loses water molecules and it converts into the phosphoenol pyruvic acid. Here the products are the PEP, that is phosphoenol pyruvic acid and water molecule. And next, last reaction in the glycolysis are, that is dephosphorylation. Dephosphorylation means here losing of phosphate group from the substrate. Okay, this is the last step in the glycolysis pathway. So here the phosphoenol pyruvic acid, PEP, phosphoenol pyruvic acid, in the presence of enzyme, that is pyruvate kinase. In the presence of pyruvate kinase, it loses phosphate group and converts into pyruvate or pyruvic acid. So here the phosphate group which is lost by the PEP is taken by ADP. Next, this ADP converts into the ATP. Here also this ADP, it is getting the phosphate group from the substrate, that is phosphoenol pyruvic acid. That's why this phosphorylation, that is conversion of the ADP to ATP, this phosphorylation is called as substrate level phosphorylation, because the ADP is getting the phosphate from the substrate, that is PEP. So the PEP, it converts into the pyruvic acid in the presence of enzyme pyruvate kinase. Thank you.